Hello, hello, hello. Hey guys and gals. Hey guys and gals. How are you doing today? How are you doing this fine day? This fine day? Brothers, sisters, Johnny Whiskey Tango coding, Whiskey Tango sharp coding. I'll get that right some year, maybe. Let's go. Let's go. I appreciate you guys and gals being here. Lurkers and twerkers. You know, I love you guys and gals dropping by. Lurkers and twerkers. And those awesome sandwich making workers. Let's go. Turn it up for sandwich making workers. Let's go. Followers, supporters of the channel, whether it be here on Twitch or YouTube, you guys are all great. Just throwing it out there because I like you to know. I like you to know. You guys are awesome. It's awesome. Turn it up. Okay, I am going to do a little bit more. Letting you know how much I appreciate you guys and gals, because you know I do. But I must finish up with chat stuff. Bear with me, guys and gals. Bear with me. I know, just for me, yeah, just I wish I had it done. That's the problem. I like dropping in the quotes and that for you guys and gals. I do. I just wish it was done already, you know? But let me finish up. It's great to have you. Whoever you are, dropping by. You're so awesome. Okay, we're almost done, and then we're going to check the stream. How's your day going? How is your day going? I hope it's going great. Do this. Get this done. Get that. Just throwing that out there. You know, that would be great. That would be great. It would help. It is creamless coffee day. Drinking black coffee. Oh, it's amazing. That was kind of sarcasm, guys. It's not amazing. I mean, those that probably like drinking their coffee black, you know, that's for them. I'm not going to say it's terrible. I am drinking it. I guess I'm just a little bit spoiled with the milk products, you know. I like to have milk in my coffee. Milk in my coffee. I like it. I just do. I did that one. Did I do that one? Yes, that's done. That's done. Got that done. Let's do this and finish up here. Okay. Yeah. Okay. This. Got that. Let's do this. There we go. That's to keep you guys and gals motivated. Okay? That's the goal. Keep you focused and motivated. Okay, I gotta close that. Okay, bye-bye. That's enough doing that. Let's check the stream quickly. Make sure we're golden. Keep you focused. All right, perfect. Perfect. That's what I like to see. Just gotta check, guys and gals. I just gotta check, make sure we're good. I don't want to be spending 2 hours talking and you guys can't hear me. Okay? Yeah, that would not be a good day for me. I would not to be in a good mood. I want to make sure that everything's good so that I could do the course / lecture that we are doing. We're doing C++ over here, guys and gals. If your plan, your goal, your desire is to learn C++ coding language, that is great. That is great. Here to support you, here to help you. To the best of my abilities, I will do my best to explain, to help, to assist, answer any questions that you may or may not have. Here for you. Now, if it's new to you, I recommend that you follow the series from the beginning. Okay, it'll help. The videos, you know, they may say 2 hours, but really it's an hour to an hour and a half of actual content, learning content. Okay, so that's the great thing about YouTube or Twitch. You can just slide the old play bar or skip forward. It's great to have you. If you want to jump right to certain sections to actually, you know, learning, the learning part or portion of the video, I won't be offended. It actually shows me that you have initiative and drive and goal and desire to just begin learning. That says a lot to me about your character. That's awesome. So yeah, so if you are dropping by for the first time, checking it out, again, it's great to have you. It truly is. Man, welcome. Welcome. You can stick around and watch that. I transfer all my videos to YouTube eventually. Well, I pretty much do them the same day. I export them if I can get my words out today. It's kind of a good day, guys. You know, it's kind of a little bit one of those days, but it's better than normal. So I think we'll be fine. In a good mood, somewhat. That's always positive. So yeah, if you want to stick around, watch, by all means. If you want to check out and watch the beginning of the series, by all means, Whiskey Tango Shark. Check it out if you want to support and watch the series. I can't keep the videos over here, guys. I wish I could. I would just keep them for you fine Twitch viewers. Because, you know, I'm going to say it. You guys are killing it over at Twitch. You guys are, man, killing it. You guys are killing it here on Twitch. Thank you for the views. Thank you for the views. It's huge. It means a lot. I'm going to leave it at that. But yeah, it's great. It really, truly is great. Keep it up. Keep being awesome. Keep learning. Keep grinding. Again, I love having you guys and gals here. Okay? You know, I don't know how else to say it. I just, you know, it's my way of saying I appreciate you. Okay? Cool. All right, we're gonna get to learning today. We're getting into doing loops, different types of loops. So yeah, it's gonna be great. Stay tuned. Look forward to it. This is gonna be fun. You're welcome to stay and watch, by all means. And yeah, let's get into loops. We're gonna do some various different types. Quick drink of coffee, and then it's time to get our thinking caps on, I think. All right, awesome. Okay, loops. We'll do a little bit of reading. And then, yeah, let's just get right into it, guys and gals, all right? I'm not going to go on and on. I know sometimes I do, you know. Today's one of those, let's get right to learning days. That's a plus, right? So yeah, throw on your old thinking cap, leave the dunce caps for all the dunces, and flick the old switch in the brainium cranium, and let's learn. Turn it up. Oh, yeah. Last thing. Do one final thing before we get started. I love doing this for you guys and gals. I do. Just want to show the love. If I can find it. There it is. I don't know what it is. It's great. That's my fam in the background, throwing it out to you guys, supporters, followers, viewers. Y'all great. You are all great. Okay, we are more on program flow. Program flow. How do you make your program flow? I don't know. Let's find out. Okay, programs accomplish most of their work. Getting into the lecture and class now, guys and gals, just to let you know, right? I guess I should quickly mention that we are doing a lecture class over here, okay? If you're looking for a 5-minute video on how to write a variable, okay, and get 1 million views, you found the wrong channel. I don't know what it is. I like saying that. Real talk. Let's go. But you guys who are watching, you know I appreciate you, okay? All right? You know I do. I truly do. I say it so much. I don't know anybody that says it any more than I do. Okay. Creating expressions and statements. You learned how to branch your program using the if statement. All right. I need to get to learning. Actually, I need to get to learning how to reading. Learning how to reading. I know that was terrible grammar or English. Okay? I know. Sheesh. Why so serious, Bob? Okay. We are gonna get back to doing different OOP, more object-oriented programming, guys and gals. We will. We're gonna do more, so don't worry about that. Let's get into learning some different other theory, some other ways or processes that we can make the magic happen in our code while we're creating programs. Because there's a lot of different things that we can learn and do. Okay? So we must carry on. Today you will learn what loops are and how they are used, how to build various loops, an alternative to deeply nested if-else statements. Looping. Many programming problems are solved by repeatedly acting on the same data. Okay? Two ways to do this are recursion. Ew, I know, cringe word. I know, guys. Just do the basic, simple recursion. It's fine, guys. That's pretty easy to do, right? Some of it can get a little bit mind twisty. That's okay. Don't worry about it. Worry about that stuff a couple of years down the road when you get a lot better at grinding code, okay? Don't need to know it all right now, right? Give yourself time, okay? Stay focused, stay positive. Give yourself little breaks if you need to, here and there, right? And then come back to it. Organizing into functions and iteration. That's a word for the day. Iterating, or iteration. Okay, you'll hear that. It's kind of the word of the day. Okay, I'll show you how to iterate. It's fun. Iteration means doing the same thing again and again. The principal method of iteration is the loop. All right? The roots of looping, so we're going back to the roots here, okay? We are kind of going through an older course outline, which is fine. I feel the theory and the general knowledge is all the same. I mean, things do change over time or whatever, but the basic foundation of coding is still the same. But I'm going to show you, I was contemplating typing this. I don't even know if it's going to run, but I want to type this code up and show you, I guess, some old school, like not basic or anything, but the way they used to do it, you know, years and years ago. Line coding and statements have changed over time, right? So some things aren't used today. That's all, really, that's all I'm going to say. In C++, a label is just a name followed by a colon. The label is placed to the left of a legal C++ statement. So labels, right? That's what I'm kind of getting at. They used to use what's called labels. I haven't seen it in code or not today in modern coding. I've not seen this. So whether it works in the program or not, I'm about to find out. A jump is accomplished by writing goto, right? That's old school, like basic. I've seen that before. is accomplished by writing go to followed by the name of a label. Okay. This example illustrates the primitive way of looping. Okay. Let's check out the primitive way of looping. We're going to write some code. We are going to do more reading and more theory. We are. But sadly, I must get rid of this point class that we made. If you didn't see that, you will eventually see it if you follow the series. Okay? Got to go to the main here. Okay, right. So we're just cleaning up here. This was last stream. If you're watching, you would have all that information. Just cleaning up. Check this. Okay. We're good. And now I gotta go here. And here. And now here. And here. And all right, that's how I always forget to do that. That's always the last thing I forget to do. Getting rid of the includes. Did I not build it? There we go. Okay. Perfect. Oh yeah, I'm going to get rid of this as well. Okay, so here we go. Let's do this. So they're creating a variable. Okay, we'll do that first. Int, they called it counter, and they initialized it to 0. All right, I'll just type it the way it's typed here. Okay, initialize counter. That's essentially what we did. We declared, we initialized, declare, initialize, declare, initialize, declare, initialize, declare, initialize. Hold on, guys. Jeez. All right, I think that's better. Okay. Loop. Here we go. Okay, so this is interesting. So we'll see if it works. I don't know if it does actually anymore. Oh, look at that. It actually accepted it. Interesting. We'll see what happens. We're going to do post. I've gone over this. Post increment. And then we're going to standard cout. I'm just interested to see if this will actually work. And let's find out. What does it recognize it as? Oh yeah, okay. Interesting. And then go like this and take our value. Whoops. And there. Okay, what else do they have? They have if. This is to end it. Otherwise, we'll be stuck in an infinite loop, and we don't want that. The counter is, if the counter is less than 5, this is kind of our end, our stop. It's a test as well. It's still a test condition. And then it says go to loop. Okay, does this even exist anymore? Wow, interesting. Okay, bit old school. And then outside the loop is another standard cout. It's a short little program here. Nothing, not really very long, guys, gals. Complete counter, and then counter then I'm just going to copy all this. And there. Okay, and then return 0. All right, it seems to have accepted it all. So let's build. Wow, there you go. I've looked at a lot of different code and different various code that people type. And this is one I haven't really seen utilized, not in the modern day. So yeah, let's see, this actually going to build and run. Look at that. Wow, that's cool. Something else that you could do. Here you're checking it out on WhiskeyTango Sharp Coding. Let's go. If you if you don't mind the old school way of coding things, by all means. That's exactly the return as well. So it kept going until it got to 5. That's really what I call the end, right? As long as the counter is less than 5, it'll keep looping, essentially. Cool. Okay, so I like it. It almost feels like going a little bit of a throwback. Feels like it, somewhat. Kind of. Not entirely, but a little bit. Let's see. So counter is initialized to 0. A label called loop is on that line. Line 56, marking the top of the loop. So that marks the top of the loop. Counter is incremented right here. And its new value is printed on line 11, which is here. Okay. Let's see, what else do they say? Not line 11, I'm reading it verbatim. Line 60, the value of counter is tested on this line here. Let's see, yeah, right? Because this is a test condition, right? I'll just go like this. It's where you have your test condition. Okay, and if the value is less than 5, the if statement is true, right? It's true as long as it's less than 5, right? And the go-to statement is executed. Cool. This causes program execution to jump back to the loop label on. Okay, back up here. So it actually goes back up here, guys, so you understand, right? So when it goes here, test condition, if it's true, it'll do this, goes back to the top. That's what it does. It's kind of going back and forth here, and it just starts going line by line again, right? That's how it works. Pretty straightforward. Not the normal way of doing things nowadays, but that's okay. I thought it was kind of a cool throwback. The program continues looping until counter is equal to 5, right? As soon as the counter is equal to 5, then it becomes false, right? So yeah, at which time it falls through the loop and the final output is printed. So essentially it falls through and just goes right to here, right? So what's happening is when it gets here, it jumps back up here. And then this is the print line right here, okay, that you see, right? So this only gets printed out once, right? It's never seen until counter becomes 5, right? Okay. So 1 jumps back up, 2 jumps back up, 3 jumps back up, 4 jumps back up, 5. Then that's when it becomes 5, right? It actually printed it, right? It would do that, but then it breaks out. Because at 4, let's see. That's interesting. 5, it still prints out 5, right? Because counter's still going to equal that number, right? But it doesn't go into the loop. It just goes straight to here. All right, let's continue. It's a little bit of an analysis on what's working there or how it's running. Why go to is shunned? Okay, go to. This is old school. I think old school is cool. If it wasn't for old school, there'd be no such thing as today's school. Okay, respect old school. As a rule, programmers avoid go to, and with good reason. Go-to statements can cause a jump to any location in your source code, backward or forward, okay? The indiscriminate use of go-to statements has caused tangled, miserable, impossible to read programs known as spaghetti code. Maybe that was probably the point where I was like, well, it's printing 5 here, which I thought was interesting. I could see it being 4 and going inside and then going back up here. Here it becomes 5. Yeah, it would still print right here. That makes sense. It would still print this line. But then because counter is 5, it won't go into this, right? Becomes false, therefore just jumps straight to here. Okay, now that makes more sense. I can see it now. All right, the go-to statement. To use the go-to statement, you write go-to followed by a label name. This causes an unconditioned jump to the label. What do they got here? Example. Let me just type it up. What else? Is that all they have for an example? If value is greater than 10, go to the end. If value is less than 10, go to the end. Well, that's crazy. See out value is 10, end. They actually had end as well, and then see out done. I don't even know if I want to type it. I'll show it to you, I guess. I'll share it so that you can at least see it. Okay, there we go. Okay, that's what I'm seeing, right? And even end here, they did that as well. I didn't see a loop here, so I'm like, well, you know. To avoid the use of goto, more sophisticated, tightly controlled looping commands have been introduced. The for, the while, and the do while. Okay, these are the common ones you see today in modern day coding, guys and gals. Okay. I mean, this is kind of a cool thing, right? It's a little bit of a throwback, and it doesn't hurt to see how code is written back in the day. It doesn't hurt, because you're going to see a lot of different code if you research on the internet, for example, right? Maybe you come across seeing something like this. If you don't know it's old school code, then you're not going to know. You're going to think it's just modern day code, and you might even think it's new, right? You know, we don't want that. Anyways, just throwing that out there, right? Just thoughts. Using while loops. All right, coolio. A while loop causes your program. I've been through all these, guys. I'm just kind of teaching it like I'm a beginner too, all right? Helping you out, right? Doing my best here. A while loop causes your program to repeat a sequence of statements as long as the starting condition remains true. In the goto example, the counter was incremented until it was equal to 5, which is true. And then shows the same program written. Okay, so we're going to do the same program using a while loop. All right, let's do it the new school way, so you can learn the new school way. All right, we're going to get rid of all that. And here we go. All right, same thing here. So this doesn't change. That's still normal. Nothing different there. Still initializing and declaring and creating a variable. All right. So now it's a while loop, okay? While loops. While test condition. I'll just get used to the habit of always putting in curly brackets, okay? I don't recommend, even with an if else. If it's just an if else, I guess I recommend a ternary. If you're just using a singular if else, I still recommend brackets. A lot of people don't use them. If it's really simple, 2-line, like an if and then an else, the compiler will know. It'll still run. You won't have any errors or bugs. As long as you don't have a lot of lines of code, then that's where it can become a problem, right? So the curly brackets, it creates that block of code that the compiler knows, okay, this is the end of the scope. Okay? All right, while counter is less than 5, the condition is still the same. Let me just have a look, right? Same condition, unchanged. And then inside is where counter plus plus is used. Take note, guys and gals. I mean, it still works and outputs the same numbers. You won't really notice a difference if you use pre or post increments. But if you practice, like, just testing out some basic, let's say x equals 5, for example, and then you go x plus plus, and then you do a standard CO just to see what x returns, right? Right? You could go, I don't know, x, right? Just to return something, and then go x, and then standard end line. Okay? And then you could test that, and then you could go x plus plus again. Right? Just for testing and learning. Okay? Goodness gracious. It's going to be one of them can't type days, huh? I really can't type days. One of those really can't type days, okay, right? And then do that a few times, right? Just for testing and learning, trying to understand what's happening. And then do, once you've done that, then do plus plus x. Okay, I'm not going to run it. I want you to test it so you can learn and get a better understanding of what's happening with pre and post. Okay? All right, let's continue. And then inside our brackets, we are going to actually have the return. Okay, counter. What am I typing today? And counter. Okay. All right. Okay, I actually typed it properly. Shocker. And one more. I should have kept those lines of code so that I didn't have to do this again. Complete. It's basically just letting you know, okay, that's it. It's complete, right? Full stop. And I'm going to do this and this and that. All right. Okay, build it quickly. Coffee. Whoops. All right, let's run it. There we go. Exact same output. All right. Coolio. So they've made it better, right? The reason they did this, the idea was to kind of get rid of that one spaghetti code, right? And the fact that go-to statements can cause a jump to any location in your source code. So they've made it more secure, right? They made it more what's the right word? Like, so that the program flows better, right? You don't have any breaks or glitches or bugginess going on, okay? So there you go, yeah, while loop. Turn that up. This simple program demonstrates the fundamentals of the while loop. All right, an integer variable called counter is created and initialized to 0, yes. And then it's used as part of the condition, yes. That all applies the same. This is still the test condition. Nothing changed there. Just like I said, you know, the way code is written may have changed, but the concepts and the theory and the way things are done naturally are still the same, okay? The body of the while loop is executed, right? So we're inside the loop this time, guys, gals, right? Compared to, let me just screenshot the other one so you can see. Oh, hold up. I'm going to fix that. I'm going to screenshot the result as well so you can see it. All right. So that's, you know, that was the first way we did it, right? The old school, using a loop. All right. Now, when they printed this, it was above it. It was above the test condition, right? So note the difference. This time we're inside the body of our while loop and returning it, which makes sense, right? It's going to increase counter here, and then it's just going to print it. Okay, and then it basically goes back inside of itself and reloops. Okay, it keeps going until this becomes false, essentially. All right, so I'll kind of read their definition here. The condition is tested, and if it is true, the body of the while loop is executed, right? Okay, just like I said. That's how it works, right? This has to become a 1, right? A true is 1, right? It's like an on switch. Think of it like that. It's that simple. If it's 0, it's off. So as long as it's on, it'll go inside. Okay? As long as this is on, or 1, it'll go inside. As soon as this becomes a 0, it boom. I don't think it even goes inside. It just goes straight to the end or to the beginning of this line. Right? I'm not inside the computer. I don't know where it's going, right? But I would imagine it just jumps straight to the next line, right? Because again, this is 0. There's no reason for it to go inside. Okay? It breaks out of it. Okie dokie. In this case, the condition tested on, which line are they talking about? In the test condition line. If the condition is true, the body of the loop is executed. The counter is incremented, right? This is where it gets increased, right? This is how you change the value under the hood, right? Values stored in a variable can change, right? And this is one way of doing that. Okay? Short of just going, counter equals 1. You know, that's not how it's done, right? Then counter equals 2, right? That's not how it's done. That's the great thing about the plus plus or the increment operator. Remember, guys and gals, what it means is, maybe some of you are wondering, maybe you're watching and you don't know. I guess I should have realized that. What it means is counter equals counter plus 1. Okay, I'll just go like that. Okay, so what happens, and maybe you don't know, this is a left-hand side, this is a right-hand side. Okay, whatever's on the right-hand side gets stored into here. Okay, so counters increased, plus 1 gets stored into here. Okay, each time it goes through, it reutilizes the last known stored value of counter, right? The last known, once it goes back into it again, right? So counter was 4, let's say, for example. Let's say counter was, let's say it was 3. Counter plus 1 becomes 4, gets stored in counter, okay? It prints counter as 4, and then it goes back up and checks again. Okay, counter's 4, therefore it goes inside. So now it's using the last known stored value of counter. So counter is now 4, then it goes plus 1, stores it in here as 5. Goes here, prints it as 5, goes back up, checks it again. Oh, now it's 0, right? Because counter is less than 5. Again, take note, it's not equal to 5, it's less than 5, right? So therefore, this becomes 0. That's how it works. Okay, that makes sense? The value or the variable that's stored in memory gets updated each time it goes into the loop. Okay, guys and gals? Okay, the counter is incremented, and on that line, the value is printed. When the conditional statement on that fails, the counter no longer is less than 5. The entire body of the while loop is skipped. Okay, there you go. Now you know your answer, right? It doesn't even go into it, like I said. It doesn't go into it if it's false, guys, okay? It just doesn't. It skips it. It goes straight to the complete. It still will print 5. Hold up. Let me just see. Let me check. Did still print 5. Counter plus plus. Let's say it was 4 plus plus is. I guess, yeah, that makes sense. Yes, because if counter is 4, right? I'm just kind of thinking of it a little bit deeper here, right? I know this. It's just paying a little more attention to the detail, right? Understanding what's happening. So even if it's 4, okay, let's say it's 4 here, right? It still jumps here. It's 4, and then it's plus 1, right? So now it's become 5. It's still inside the code of block or block of code, right? So we'll print 5, okay? Just because it printed 5 doesn't mean that it's broken. It got inside the block of code because it was 4 right here. That's why, okay? Because it's 4 is less than 5, it goes inside. 4 gets increased to 5, and then it gets printed here as 5, okay? All right. Let's throw in the yays, because that's got to make sense to you. Half awake, I don't know, guys, gals, but here we are. Let's do this. Okay. So, what? Why do you have to? Double commercial too? You're really annoying, aren't you? Uh, the quickest way for me to skip commercials is to loop, but they're forcing a double commercial. Unbelievable. Okay, here we go. The entire body of the while loop is skipped. Program executes, falls through. It is worth noting here that it is a good idea to always use braces. That's what I've always recommended, right? For me, it's cleaner. It's more organized for me myself. That's me. Okay, everybody's gonna have different preferences, but again, if you have multiple lines of multiple statements, right? The program or compiler is not going to really know when that ends, right? This kind of tells the compiler it's out of the block of code, end of scope. It's kind of like a signal, like, hey, I'm outside. And for visual reading, just for human readability, it's better on the eyes to read. Let's say it was an if else, right? It depends, right? What you're doing. This is just a simple if else, but readability, it's a little more easier to read. You know when it starts and when it ends. Okay, I'm gonna leave it at that. You know when it begins and you know when it ends. It's clearly obvious. When you don't use them, it's a little bit harder, right? It's easy if it's only 2 lines, like a single statement in the if and a single statement in the else. It's readable. We could read it. It'll still work. It'll still run. But again, if you go multiple lines or multiple statements, then it can get a little, Okay? Recommended to use braces around the block executed by a loop, even when it is just a single line of code. That's what they're recommending, okay? So if you're one that likes curly brackets, you're doing just fine. This avoids the common error of inadvertently putting a semicolon at the end of a loop and causing it to endlessly repeat, for instance. Yeah, no. I didn't even want to like bring it up, but what? That's wild. I could see that happening. Yeah, be careful of that, guys. Okay, so I'm going to go like this. I'm going to get rid of that. Okay? And they put an actual semicolon there. In this example, counter plus plus is never executed. Okay? Things that you got to be aware of. And plus, I've never seen a semicolon after a test condition. I've never seen it. Ever. And I don't know. I have no answer for that. But, there we go. It's easy to fix. It's easy to add in, take in, and add in curly brackets. The program works nice that way. Okay, yeah, so no semicolons after your test condition. It's always a block of curly brackets. All right, we're learning here today, guys and gals. A little more serious today. Probably should have more serious days. I imagine a lot of you appreciate it. Okay, what else? Yeah, so there we go. So it's written like this. Okay, so just like I was showing earlier, I'm gonna go like this, just so you know. And then inside here is your statement, right? Anything that ends with a semicolon is a statement. Okay? That's the pattern. Now, I could have did it like this. Okay? And Control KC. There we go. A little more extra forward slashes, but let me just put it back like that. It was a little bit easier for you to read. Condition is any C++ expression, and statement is any valid C++ statement or block of statements. When condition evaluates true, statement is executed, and then condition is tested again. This continues until condition, right? I call it test condition. It's all the same, guys. This continues until condition tests false, at which time the while loop terminates and execution continues on the first line below the statement. Alright, anyways, you get the idea, I hope. Exploring more complicated while statements. The condition tested by a while loop can be as complex as any C++ expression. This can include expressions produced using the logical and, or, and not operators. Okay, so I do have one example here I could do. Let me just see what I have here for notes. Let's do some stuff for fun. Let's see. I'm just trying to think of something funny. I don't know. Fish. Sure. Let's throw in fish. Okay? Int fish equals 0. Right? So I'm gonna go like this. And we're just gonna do something kind of funny, but still just as simple. While fish is less than or equal to 5, this is okay the way it's written. For myself, you could even hard code this 5 if you wanted to. We could call it int end loop if you wanted to, right? Equals 5. I could create a symbolic literal. It works as well. It could also even be a const, right? And then I'm going to make this into a C end loop. Okay, and then it's clear what it is. Okay? You following along? Now, I don't know. I'm just adding the C. I've seen, like, for a macro, I've seen m_pi. And M stands for macro. So I kind of just been following the same by using C. But normally, it just says end loop. And if somebody sees all uppercase, that infers constant, right? If they read your code, let's say this is line 5000, right? They might forget that about the constant after they've been through 5,000 lines of code. I'm just saying, for example, they might have forgotten, oh, what's end loop again, right? They'll look at it and go, oh yeah, just by the way it's typed, they'll know it's a constant. Okay? All right, so while fish is less than, remember this is equal to, so take note, it tests for the less than and it tests for the equal to. So there's two tests being done there at the same time. All right, just to be aware. A lot of times I don't like that extra test. So let's say I wanted it to be equal to 5 but less than, right? So if I want it to be equal to 5, I'll change it to 6. That way I'm guaranteed to get 5 to be included. Make sense? That's what I do. And then you actually get rid of that equal to, right? Be gone. Now you've sped up your program just simply by increasing this number by 1. Simple, right? So fish is, this is just for laughs, guys and gals, okay? And just so you can see, right? So it's a simple, we're declaring and initializing, we've created a constant. All the other stuff here, just ignore, guys. Just focus on this. That's it. That's all we're working with right now. Everything else is just ignore. Okay, build it. Undeclared. Okay, cool. So let me try to decipher what it's saying. Counters undeclared. Okay, right. It's right here. Okay, so it's reading this line. So I should have deleted it. That's all. I forgot to delete it. No big deal. So instead of deleting the whole thing, I'll just change the variable. All right. Whoa. We're stuck in an infinite loop, boys and girls. We're stuck in an infinite loop. Why is that? Okay, in this situation, the program will continuously run over and over and over and over and over. Did you notice that it was 0 all the time? Okay, did you notice that? If I didn't stop it, it would just keep going. Okay, so here's why. Okay, you're wondering, maybe you're wondering, right? So just kind of just think about it a little bit. Okay, just try to understand what's happening. Fish is 0, right? And as long as it keeps going into this test condition, fish is always going to be less than the end loop. Right? It makes sense? You're following me so far? So therefore, our test condition is always going to be true. Okay, it's always going to be true. And why is it always going to be true? It's because we're not changing the value of fish. We need to change it in code so that we don't get that continuous loop, right? So I could go plus fish, and that's what you do to change it, right? Now we're actually changing the value of fish to end that. We had an infinite loop there, guys and gals. Thankfully, I built my PCs, 2 years old, still grinding, still doing videos for you guys and gals. I designed it, built it, you know. I don't know, I love doing it. I could design PCs and build PCs. It's still grinding for me, still doing videos. I love it. She's a beauty. It's also 64-bit architecture, so it can handle that infinite loop while streaming. Not wild sauce. Okay. So there's a couple of ways I could have did this. It doesn't have to be before the statement. I could print the statement first. Let me just comment that out. Or I could go fish equals fish plus 1. Okay? Or I could go fish plus equals 1. Or I could go plus fish. Whoops. Didn't mean to do that. Right? So I could increment it before my statement, before my print statement, or after. It doesn't matter. Okay? So here's 3 ways of doing the same thing. Whoops. This is 3 ways of doing basically the exact same calculation. It truly is, guys and gals. Oh, goodness gracious. Right? I could either go fish equals fish plus fish. Remember, left-hand side equals right-hand side. Okay? Right-hand side is temporary, gets stored into left-hand side. Left-hand side is permanent, stored, variable address, has a location in memory. Okay? It's the variable on the left that actually has the value. Okay? So I'm updating fish plus 1 here, gets stored in. Or this is a shorter way of writing this. Okay? So if you see this and you're like going, what is that? That's this. Okay, this is the condensed version of this. This is the condensed version of this. Okay? Or you could just simply go with the increment operator. Your choice if you want to go pre or post. Okay? It's up to you. All right. So with that said, I'm going to get rid of all this because you get the idea, hopefully. I don't know. I'll put it all back in case you want to like write it down or something. There it is for you. Okay. Let's build. Just to clean things up, just get rid of some stuff that's kind of in our way. Just to make it easier for you guys and gals and it's less clutter. We'll hide some of that other stuff. All right, let's run it. There we go. No more infinite loop. This time it actually printed 0. Okay, so let's have a look. So it's 0 here. Okay, it's less than our constant, which is true. Goes in, prints it first. Haha, see? Prints it first. Then it gets incremented. So that's a little bit of a difference for you guys and gals so you can see, right? Oh, look. Our counter's complete at 6. Okay, so going in, so 5 is less than 6. It goes inside, it prints it. Then it increments it. So now it's 6 here. Goes out. Does the check. It still has to do the test, right? 6 is, well, less than 6. Well, that's when it goes, well, 6 is 6. So it becomes 0 here, right? And then basically jumps to here, right? So that's why you're seeing 6. Make sense? I hope so. Trying to keep it as basic as possible for you guys. Now, I'm not saying that in a mean way. I'm trying to say it so that it's easily understood, right? Without overcomplicating it, making it confusing. Because really, it's fairly straightforward, right? Okay. And if you didn't want it to start at 0, we could change that to 1. Right? You're in control of your variables, right? So let's say you didn't want it to start at 0, you wanted it to start at 1. Okay? We still get 6. Okay, now it's up to you. It's your program. Whatever you choose, whatever starting value you want, that's up to you. Right? You're the designer. You're the programmer. Okay? And I could do it. Like I could increase this to 26 if I wanted to run 25 times. Right? Boom. Okay. Pretty awesome, huh? Again, you're in control of the values, however many times you want it to run. Just depends on what you want it to do. All right. Anything else on that? Oh yeah, we could also do stuff like this. Let's see. I'm gonna still have an ending value. Okay, I'm gonna leave it at 26. But check this out. So let's say you wanted, instead of going +1, let's say you wanted to increment it by another value. I don't know. We could call it a. I don't know. Let's see. What would be a good name for it? I'm thinking jump, but I don't know what else to call it. Like a skip value, skip counter. I don't know. Skip value, skip val. I don't know. Let's just say 3. Okay, it's not going to be a constant, but what I'm going to do is what I showed you earlier. Remember, I showed you fish equals fish plus 1, right? Or I could have wrote fish equals, no, sorry, plus equals 1. This time we're not using the increment operator because the increment is a +1 situation, right? It's either a -1 or a +1, pre or post. It depends on what you want to do. In this case, I want it to skip by 3 instead of 1. Okay, so I'm showing you this, but instead I'm going to take advantage of my skip val. So what I'm going to do is go fish plus equals my skip val. So just so that you understand what I've got there, it's basically the same thing as saying fish plus skip val. Okay? Except this time I'm using a symbolic constant versus a literal constant. Okay, makes sense? So what's going to happen if we, instead of incrementing by 1, we're going to increment, we're going to kind of do like skip jumps. Make sense? This is our ending number. It's like, the test condition is what stops it. It's like, hey, end at this point, which is 26, okay? Look at that. 1, 4, 7, 10, 13, 16, 19, 22, 25. And then it stops at 28. It actually went all the way to 28. Okay. That is because it's still being incremented inside, right? So it comes inside as 25. Right? 25 is less than 26, which is true. So inside here it's 25. Remember, it gets printed here. Then it got incremented, comes back out, does the test condition again. That's when it jumps to here and prints 28, because 25, it still gets incremented, right? That's where the 28 comes from, because it's still inside the loop. It gets incremented here, becomes 28, comes on out, goes inside. Oh, 28 is actually greater than, so therefore this becomes 0, and then just skips right to here. All right? Just so you understand the code a little bit, right? Because you might be going, well, why is it returning 28? Hopefully you understand. I hope you understand. Right? Pretty straightforward, right? And plus, take note, right? Your return's going to be dependent on whether you have this in front. It's almost like I copied an empty space. Okay. right? So it's going to actually increment first and then print. So let's just see the difference. Okay, we still, this time it printed 28 here. But 1 is actually not printed, right? So because it gets incremented first, right? That's why 1 wasn't printed. Following along? It depends when you're incrementing it, right? Is it before you print it to the console, or is it after? Okay, bit of a difference in your output. All right. Okay, yeah, cool. All right, so let's do this other little program I was going to show you. Right, there you go. Hopefully you got a better understanding there. Just check it. Let's go. What? Okay. The stream's been going okay, I hope. No issues. Let me just check my notifications. Okay, everything seems to be fine. I was a little worried for a sec. I think we're all right. Okay, let's start grinding out some code. We're going to create some unsigned short, smalls, unsigned longs. We're going to work with kind of the code that they use. I'll just show it to you. Okay, well, I'm not showing you the code, but I'm going to actually type the code to you, but I want to show you this just to kind of refresh your memory. What's an unsigned? They're using unsigned short and they're using unsigned long. Okay, so an unsigned short, because you don't need to write the int, right? It's basically 0 to that. These are commas, okay? Not decimals. So 65,535. All right, and you have to watch the section on min and max values work like a clock, okay? You have to follow the series. It's something critical to understand what happens when you increment or even add 1. Okay? You gotta understand min and max values, what happens when you get to the maximum value. All right, follow the series, guys. I'm not going to explain it today because the awesome people that have been following the series, I'm keeping moving forward for them because that's what they deserve. They're putting in the time. I'm going to keep moving forward for them. I'm not going to keep jumping back and forth, right? I'm being nice here to stuff I've already explained. It just depends on what I'm doing. I'll explain some things, I don't mind. But I'm not going to go talk about something for another half an hour when I've already done a video on that and they've watched it, right? So I recommend you follow the series. If you don't understand that part, I recommend you check it out. Again, the videos are all backed up on YouTube, Whiskey Tango Sharp. You're welcome to drop on by. Whether you like YouTube or not, I mean, that's up to you. I don't know. That's fine. Your decision, your feelings. But yeah, you're welcome to stop on by and check the series out there. All right, great to have you. And what's the other one? Unsigned long. Okay, so all positive. Anything that's unsigned, just think positive. Really. Okay, 0 to 4.3 billion, right? A million is 6 zeros, right? A billion. All right. I'm just going to bring that over here. Okay, back to this. Let's type the program. So local variables. I'm still inside my main. This is kind of where I'm putting my local variables. It's still inside the main. All right. Do I have today's lesson? All right. We're okay. I just had to pay attention now because I did have that at one point. Maybe I just got rid of it. All right. So unsigned short. And we're just kind of declaring them for now. Okay. I am technically initializing them as well. All right. And we're going to have an unsigned long. I'm going to call them long vowels. Okay. And short vowel. Okay. Short for value. So it makes a little bit more sense. And we're going to have a const as well. Const. It's also an unsigned short. Whoops. My bad. Almost messed that up. Okay. And we're going to call it, it's a constant, so max small, right? So kind of small val, okay? Max small val is equal to 65, 535. Okay, this is legal the way I've typed it. You can use a single quote, like a comma. Now, when you're working with large numbers, it's also human readable, right? There's two ways of writing it. You could write it like this. You never write it like that. You're not allowed the spaces, okay? Program won't recognize that. But if you want some human readability, just put a semicolon. Single quote. I'll build it. You can see everything's going to be fine. No issues. Okay, now what's that 65535, right? Remember, it's a small. And what's the max value of our small? 65. That's 65,535. All right? As a matter of fact, you might actually see it go over, but we'll see what happens. I haven't run this code. Let's just run. Let's grind it. Let's see what happens. A lot of times I have my own examples, guys and gals. Or I'll just kind of follow the program itself. I guess it just depends on what I want to kind of show you guys and gals and teach. For the most part, I am following the series. Standard CN, right? And we're going to enter our short vowel. Stored in short vowel. And then I'm just going to copy this, and then this time we're going to go large number. I should put a max or something because the user is really not going to know, right? You kind of almost have to be a little bit explicit with whoever's using your application, right? Because they're not going to know. You got to assume they have no clue, right? Just assume. Don't treat people like they're dumb by all means, but just assume they don't know, right? Small number could be, I don't know, we could maybe give the user something like, I don't know, min value, I don't know how we type it. Whoops, didn't mean to do that. Course, Whoops, Control X. I'm gonna go maybe put something like range, min value 0 to, I don't know if it's the best way to write this. You know, it kind of makes sense, right? And max value 6.5, and then use actual comma because it's a string literal, so you're allowed to. And then I'm going to use a \n inside my string literal. Okay, there. Now we're kind of giving the user a prompt here so they have an idea. I'm just going to build it, and let's just have a look. Okay, I'm going to run it. Enter a small value. Oh, look. Range min value 0 to max value. So I'm going to enter 2. And 100,000. Okay, let's say I entered 100,000. Well, actually, I'm not quite done yet, but I'm just going to put 10,000 just for now. 10,100, that's fine. It breaks out of the program because all I'm doing is enter and storing values. I haven't really done anything more than that, right, guys? Okay, so this is good. This is a nice little prompt for the user. Now he knows a range, he or she. They know a range, and so they have, you know, an idea of what value range they should be, or what numbers they should be entering. We could even go as far as going integer range or something, right? Just so they know they're integers. Everybody should know what an integer is. All right, standard cout. Let's print out the small value. Why aren't they printing the large in the beginning? I don't know. So I'm just going to go like this. Just kind of follow it a little bit. And then we're going to return the small short val. And then they got something like this. And I'll just do that. Pop, pop, pop. Maybe it needs a space. I don't know. I'm going to go like that. And then we're going to have 2 test conditions this time. Okay. While, it's a while loop we're still doing. While, test condition, curly brackets. Let's finish our test condition. While small value or short value. While short value is less than large value or long value. We are using a long, right? That's why we're the user doesn't care if it's a long or a short. They don't need to know short and longs. All they need to know is small or large. Okay, while short value is less than long value, and remember, and means the left side of the and has to be true, and the right side of the and has to be true. And smaller, has to be smaller than, our maximum. If you're wondering where you use the maximum, typically it is used inside our test condition, okay? All right, now inside this, we're going to use an if statement because you can have if statements as well, right? So it'll go inside this block of code, then it'll go into the if statement and do its own test conditions. This time we're going to actually take advantage of modulo. All right, cool. If you're following the series, you should have an idea what modulo does. Again, I'm not going to get into that right now. 5,000 could be something else that we could do. We could go const. I'm going to go like this. Right? Good programming. Max mod value. Okay? And that's going to be 5,000. Okay? Max mod value. All right, instead of, because I could have hard coded it, I could have hard coded 5,000 in there. Okay, whoops. I could have, but I recommend just getting used to working with symbolic constants. That way, in your code, you could reutilize that variable. Maybe somewhere down the code, you're going to use it again, right? You never know. Just depends on what you're building, what you're creating. You may or may not. But at least now you know what this value does. You know its purpose. You're the creator of it. You can change it right here in code. Now, if you needed different values, of course, you're going to have to create a second variable, right? Okay. All right, let's continue. So I'm going to go undo, whoops, redo. All right, so if short value mod our max mod value, okay, we have to compare that. So this is a left-hand side, right? So this is going to mod, and it's going to create an integer value, right? So it's just going to be a number, right? What does that mean? Right? I got to point something out here. I could put, this is something that you need to be fully understand, guys and gals. I could put a random number in here. I could go 2, 3, 4, 5. This is always going to be true because any number non-zero, our test condition is always going to be true. So if I don't compare it to something, that means this is just going to spit out true all the time because it's just a number. Do you follow me? That's what modulo is. We're taking a number, we're going mod another number, and it's going to return, well, it's going to turn out to be just a singular number, a singular whole number. As long as it's not zero, it's going to always be true. I could put 5,000 in here. It's always going to be true. I could put 1 in here. It's always going to be true. I could put -1 here or -12. It's still going to be true as long as it's not zero. Okay, so any number is always going to be true other than 0. Okay, so looking at this is actually just what I've typed here is going to give us a singular number. Okay, it's going to do a calculation. And if you know what mod does, you know what that calculation is, and you know what it's going to return, or you have an idea. It's going to return a singular number. Well, again, I need to give more information. I'm not done here. That's kind of what I'm trying to get at. So I'm comparing this as a left side, and I have to, as long as the mod is, whoops, equal to, this is where you use your comparison operators to 0. Okay, if whatever happens in this calculation, if it's equal to 0, it's going to go inside here. Okay, so here we go. I'll just show you, I'll kind of give you an idea what it's going to do. We're going to just call it a dot, but this is what they have in code, just so return a dot. Okay. So we're going to break out of that. So anytime it's 0, this is kind of like a test, right? For you, so you know it's working. We could call it a dot test. Anytime it's a 0, it's going to print a dot. Okay, makes sense? And then we're going to increment. Okay. I don't know, just me. I prefer the pre versus the post. It's up to you what you want to do. And we have another constant in here, so I don't know. I could create a new constant. This time I'm going to go equal to long val minus 2. I'm just going to show you the long version, okay? Long val equals long val minus 2, right? Or we could go minus equals 2. It's the same thing. Okay, guys and gals? I explain these things so that you know what it is. All right, so that's the inside. That's our while loop. Okay? Our increment's happening here, and our long value is going to be subtracted by 2, apparently. Okay? Reasoning logic behind it, I don't know yet. So, we're going to do a new enter first. Small value. I'm going to uppercase this as well here. Small value is this. Oops, guess I could have kept it. And then we're going to do large value. I'm going to put a space. Large value. And then we're going to return. Well, large value is long. Okay. And then we're going to finish by cleaning the buffer with the standard end line. Even though I thought I had one here. I have one here. That way I'm guaranteed. Cleaning the buffer. Te buffer. Cleaning te buffer. Te. Meh. Te. Alright, there we go. That's kind of all of it, almost. Yeah, that's all of it. Alright, build. And let's see what happens. Alright, let's run it. Enter a small number. Okay, our range is 0 to 65,535. Okay. I'm going to enter the value 2. Enter a large number. I'm going to enter 100,000. No commas, no spaces, nothing, guys and gals. Okay. So I just go, I know 100 has 2 zeros. Finish it with 3 zeros. 1, 2, 3. And enter. Okay. Small values 2. Our max value was, we do have the range for a long. What's our long again? Our long is, it can handle it, right? A long, unsigned long, right? It can handle it. So we're in our range, we're fine. Okay, things that you have to be aware of. And it wrote it, so, let me just have a look here. We got this other ... going on here. That's why I added the space, right? That's that space there. So it printed small value right here on this line. And then every time it was 0, it printed a new dot. So we have 1, 2, 3, 4, 5, 6 new dots. Small value 33,335. Large value 33,334. Wow, that's wild. So remember, it's a mod process, okay, guys and gals? You might not fully understand what's going on. Let's see what they have in their breakdown, okay? Just to have an idea. This program is a game, okay? Enter 2 numbers, one small and one large. The smaller number will count up by ones, and the larger number will count down by 2s, which makes sense. This is plus plus 1, and then this is going to be minus equal 2, right? It's doing the skip jumps. We're skip jumping every 2 here, right? Until they kind of meet. That's what's happening. That's kind of cool. The smaller, okay, and the goal of the game is to guess when they'll meet. Haha. That's kind of cool. We could put any range, because how would you really know, right? How would you really know? Right? It's not half of 100,000, right? Most people might guess half 100,000. They might guess 50,000, right? Obviously, it's less than 50,000 where they meet. You got to think about this too, right? Because one's going up by 1 and the other is going down by 2, right? That's a pretty cool little guessing game. I like it. I like it. Fun little game you could have with your brother or your sister or your parents. Have a fun little game with them. You go, check this out. Look what I did today. Have fun with it. It might actually turn out to be a fun family Friday event. You never know. Let's see. The numbers are entered. Sets up a while loop. You kind of have an idea how the while loop works, right? Small doesn't overrun the size, right? We need a max. Right here, right? Remember, this is an and. As long as short value is less than long value, that's going to be true. Again, both sides have to be true in order to get into this while loop. All right? The value in small is calculated modulo 5,000. This does not change the value in small. However, it only returns the value 0 when small is an exact multiple of 5,000, right? Makes sense? Right? And it totally does. As long as this modulation process, mod process, is equal to 0, it'll go inside here and print a dot. That's what these dots are. So 1, 2, 3, 4, 5, 6. It's gone in it at least 6 times, right? Where it equals 0. When either of the two conditions in the while loop fails, the loop ends, right? It doesn't matter which one fails. As soon as one becomes 0, that's it. The modulus operator and compound conditions were covered back, like we already covered that, right? In the section of working with variables and constants. Okay, guys and gals? I don't know what video that is. We're doing numerous videos. It might be called operators or something to that effect. I don't know. All right, there we go. Let's drop the yays in for funsies. Why not? We're almost there for time. That's wild sauce. Time flies when you're having fun. There's another little program here. Maybe I'll write that next day. It's a little bit longer. It's going into introducing continuing breaks, right? You kind of need to have that understanding, especially with breaks. Breaks are utilized in, there's kind of it's something I haven't gone into yet, but you've obviously learned about if-else statements, and you could have if, else if, else if, else if, else if, and I could go on forever, and then you could end it with an else if you want. It's not mandatory to end it with an else, but you have that option. But there's this other concept called switch cases where break is used. Okay, so just as a heads up on that. I may or may not get into switch cases. I probably will. Imagine it's in this course outline. So introducing continue and break. That'll be kind of the next thing. Whoa, how many things do I have open here, Batman? Let's see, maybe one little short program. Creating a program where a user enters a random number 5 different times, and lastly, then totals all the numbers for them. Okay, I'm gonna clean this up. You guys have the code there, right? I'll just kind of scroll. That's all the code there if you want to practice it. Okay. It's all right there. Short little fun game. And I'm going to get rid of these. Now you can create these extra constants and these extra variables. That's up to you. I recommend it as good practice. You might as well just start getting used to doing it now. You don't need to put the C in front of it. It's just something I do. Anybody that reads this is going to know that it's a constant. They'll know. Anybody that reads your code. If they see you utilizing this in your code, they're going to know that you have an understanding of what you're doing, right? They'll look at you in a better light. All right? So, I mean, yeah, I recommend practicing. You do you. It's up to you if you use it or not, but I do recommend it. Okay? We went into that. Symbolic constants, literal constants. They have a reason and purpose. Okay? Or a purpose and reason. Okay. We're just going to do a little short program here. And I'm going to go n is equal to 1. That's going to be our starter. And then we need a number for the user. Okay, and I'm just going to initialize it to 0 for now. Or I'll just, maybe you like using 0. So I'll do the same. Okay, I could have typed number user. I'll just do that so it makes sense. Okay, while n is kind of, I could make it a constant. It's our starting number, so I could call it start num. Or you could just go with a single variable like I have. While it's less than or equal to, let's say I wanted a constant max number, right? Const int max val, we'll call it, is equal to 6. Okay? And instead of using the equal to, so I get rid of that extra check, because the number was 5, so I just increased it by 1, just so I could get rid of that extra check. That's kind of what I like to do. And there we go. So if you have a specific max number, it's kind of your end loop. It's what stops the loop. It ends it. This is our end case. Okay? Without this, it'll just keep infinite looping. Right? Well, yeah, and also we need the increment operator as well, right? So we're going to prompt the user for some numbers. Oh, wow, cool. And we're going to ask the user to enter some numbers. And so we're going to begin with 0, because, you need to at least give it some value for memory. And then inside this, we're going to go plus n. Okay? We're incrementing n, right? Because this is our max, right? We have to increment our n value. This is our start. I'm just going to call it that now, because when we get into some other stuff, right, this is kind of our end, I don't know, not like recursion, where recursion has a base case, but end loop, I guess you could call it. And then this is our increment, right? It continues the loop, right? Increment for loop continuation, right? Those are your three main parts: start, end, and loop continuation. They're really key. Okay? Those are your three steps. All right, and that's it. So this program, instead of returning some numbers to the screen, we're going to get the user to enter some numbers. Okay, let's find out. What's it do? We're just starting out some basic code here. Let's check it out. Okay, I could have prompted the user to, I could have said, hey user, enter some numbers. I'm just going to enter some numbers. It's allowing me to. I'm even hitting enter. And there, that's it. It breaks out. So that's good. At least it broke out of it. That's a plus. I was able to enter 1, 2, 3, 4, 5 values. Again, we're using the same variable, so it gets updated each time. So in memory, if I printed the last value, it would have printed 32, right? All these values get overwritten or replaced. Make sense? This is basically a user enters a random number. I could have prompted the user maybe something, give the user a prompt saying, I almost wish I kept what I had typed earlier. Integer range min value 0 to max value, and I'm just going to use the same. I mean, I doubt I'll go that much, but 535. I'm just going to say that just for example, okay? There we go. At least now the user has an idea what they should be doing. And lastly, then I could have even used what we used earlier, which is a unsigned short, right? I could have changed these to unsigned short here, right? Right? And I should, just for some sanity checking, and then n is, right, I could have did some protection here too, right? Max max short value, whatever, something to that effect. 65, 535, a little extra protection. And as long as n is less than max value, okay? While the n is less than max value. Sorry, wrong one. While user number is less than max value, right? It won't go into this, so it's a little bit of extra protection. Sanity checking, I guess, if you will. And then we can total all the numbers, okay, in the while loop. So again, we just entered a bunch of numbers. Haven't done anything so far spectacular. Let's run this. Okay, everything seems to be fine. Okay, good. So far, so good. Starting number used for our test. There's our start. Starting total. Oh yeah, we could do total now. All right. So starting total, this is where we're going to add some numbers and then actually return the addition of it. Cool. So I guess it could be an unsigned short as well. Probably should. Oh, if they get added together, maybe an unsigned long. Just depends on what you're doing. I guess long would protect you. Oh, I also should have like greater than 0 too, right? Something to the effect of, let me just finish this. Kind of taking it a little bit further than I need to, but I'm just showing you guys and gals some different things that you could do. I don't know, we're just gonna call it add total loop, something to that effect. Okay, and it's gonna start at 0 as well. It's just random variables. I'm not going to get too specific. So I'm going to go like this. And I'm going to go like this. I'm going to have some... And it also has to be greater than 0, right? Greater than 0. And with an and. Okay? Did you notice I actually put these two together? You see that? So this is like a right side. And this is a left side. So both of these have to be true as well. And this has to be true. So some real added protection. Call it sanity checking. As long as the user number that's entered is greater than 0, it could be 0 as well. So I could say, technically speaking, -1. But again, that doesn't fall under... a short, right? That's kind of out of the range. It's not in the range, right? So you got to be aware of that. So as long as the user entered number is greater than 0 and less than the max, we got that protection. Okay? User entered value protection. Perfect. Okay? So now we have to add our total, right? So that's what we need to do. So we need to, all those user entered numbers, we're going to add it to the total. So take this, and I'll just show you the whole process. The total plus whatever the user enters. Okay, I'll just type it like that. Again, I could type it like this. Plus equals, and it's the same thing. Okay? These two are exactly the same thing. Okay? But you only want one of them. You don't want both. So pick one. Okay? It'll do the same thing. You're not going to have any breaks or anything. All right? So whatever the user enters, it's going to add to the total. And now, outside our while loop, we're outside the while loop. Let's return that value. Okay? Take note, I've declared it above everything, right? This is a local variable, remember? We are inside int main. So you got to think of this logically. Can the program see that variable outside the while loop? Okay, can it see that variable outside the while loop? Let's find out. Okay, I don't know. I'm just gonna call it loop total for now, so you guys know what it is. Okay. Loop total equals our total. Look at that. It sees it. Yay. Okay. The reason is, guys and gals, is because, well, one, it is a local variable, and we've declared it outside. So if I declared it inside, if I went like this and declared it inside, I had to go like this. If I declared it inside, now, right, these are the little details you need to understand, right? Because this now becomes a local variable, local to the while loop. All right. Cool. So I'm going to undo that. And we're going to keep our variable so that it's visible. Okay, let's go. And let's run this. Okay. Whoops. 0. Just broke right out of the loop. You didn't even let me enter anything, Bob. Okay, while n is I haven't even entered. Oh, hold up. Okay, I'm being silly. I kind of have to enter the number before the condition, right? But the thing is I need that inside the condition, okay? So being a little bit silly, but this is kind of not really doing much. One, I need to, I just wasn't thinking ahead here. But now I totally understand what I did wrong here. So right here is a test condition, right? It's not really testing anything because I'm actually entering the values inside the while loop. So that's where I'm being silly. Okay, that's my bad, guys. So I would need to enter the numbers outside the while loop, which is fine, but I also want to keep re-looping so that the user, that's kind of the idea with the while loop, so that I could get the user to continuously enter values. Okay? Silly days. All right. I'm going to get rid of that and that. Hopefully I fixed that. Now our max is really no good anymore. That's still good. These are still good. Okay, we're going to leave it. Do we have a start? Do we need this to start? No. We don't need that start, do we? Start. Where's start? Start is 1. Yeah, start is 1. We do need the start. Okay, we're good. Let's run it again. It broke right out of it. Is what it did. I didn't even get to enter any numbers. What is up, Bob? All right, let's enter some numbers. Okay, 25, 35, 14, 69, because yes, and 45. Let's go! Let's go! Let's go! So that's a pretty cool little program, right, guys and gals? As long as you set it up properly, right? You can create redundancy. I guess you probably could get a user to enter a number initially, right? You would have to kind of set it up where the first value, right? Prompt the user beforehand, and then you could use those comparisons. It probably would work. You just got to do a little extra testing. It's up to you. You want to try it out, you can. I got to end the stream, and I just wanted to finish up with this little program, which is kind of cool, right? So it's kind of a little program where you can get the user to enter values until it reaches the maximum, and then it'll stop, and then it'll actually add the total. As it's while looping, it's adding, so it'll keep doing it. It keeps adding, and each time the value is stored, then it gets updated, then it gets stored, then it gets updated, then it gets stored, and then it gets updated. You get the idea. And then it reaches max, becomes 0, then it'll print out the final total. So that's a cool little kind of quick calculator. Pretty awesome, huh, guys? Essentially a little quick calculator program. All right, I'm going to leave it at that. I'm just going to leave that there in case you want to try it out. Again, this may or may not work. I need to go kind of undo to bring back that other code, but I'm not going to do that. If you want to try it out, you can kind of pause or go backwards in the video. If this is, if you're watching this when it's not live. Again, it's great to have you. That is it. Johnny with Whiskey Tango Sharp Coding. Appreciate every single one of you that watch. Again, next stream is going to be we're going to talk about continue and break. We're going to do some more while loops, while true, and then implementing do while loops. So yeah, stay tuned. That's kind of the plan for next stream. Great to have you. Thank you for watching, following along. Appreciate you. You know I do. I will see you in the next live stream, live video, or not live video. That is it. Johnny's saying much love. Peace out. Have a great day, evening, noon, night, whoever you are, wherever you are. Take care for now, and peace out. Peace.